Hello, this is Logan McDaniel. I'm going to demonstrate user acceptance tests for all functional requirements of my online bookstore project, plus the extra credit feature consideration features. You'll see in this demonstration the desktop GUI built with Tkinter. You'll also see the Flask backend terminal showing incoming API calls, as well as the MySQL client where I'll run queries to prove that data is actually stored and updated. Here you see the backend terminal, the front-end terminal, and the MySQL client. So with everything running, we have our GUI here, and we can start with FR 1.1, user registration. A new user must be able to create an account. Required field username, password, and a valid email address. Passwords must be securely hashed on the backend. So let's do this by registering a test user, or test customer to be more precise. And here you see that the GUI says registration was successful. You can now log in. So really quickly, we will view the API call for registration here. And this is how the backend handled it. And in MySQL, we can quickly check this as well using this prepared query. And here you see, after we run it, that the created user row is there, the role is customer, and the password hash is a long hash string, not the plain password. This confirms registration works and passwords are stored securely. So moving on to FR 1.2, user login. A registered user must be able to log in using their username and password. The system must authenticate the user and establish a session. So we can go back to our GUI. And we'll use the customer we just created. From here we can click login. And you can see that this customer's page opens. We can point back to the terminal and see the login call, and we can also use this SQL query to show this in the database as well. We'll paste this and enter it, and this shows that a new auth token was created for Logan customer. That's the session token that a client now uses for authenticated API calls. So now we have FR 1.3 session persistence. Once logged in, the user should remain authenticated until they explicitly log out. All subsequent actions requiring authentication must be tied to their session. So to do this, we'll stay logged in as Logan customer. In the customer screen, we can run a simple search. Boom, search books. We'll revisit this later, but for now, we will point to the terminal. And we will see that this is now here. The backend processes the get API books with a valid authorization bearer token header. Since the token is valid, it returns 200 in results. And the database session behavior, you don't see any new login, but you do see further endpoints using that same token. So now if we go and click, say, log out, we're now logged out. And the backend log also shows log out with 200, and the token is deleted, and we can see the token deletion by running this query. And we will paste this. Don't forget the semicolon. And after logout, there are no active tokens for Logan customer. This proves the session only persists until explicit logout, and as you can see here, that is the case. Moving on to FR 2.1, book search. A logged in user must be able to search for books. The search functionality should accept a keyword. Let's go back to the GUI and log back into the test customer. We can log in. Here we have the search for the books, and previously you just saw us do code. This brings up this book. For this we can do something else, say Python. and we can search books, and here we have the results. And the backend terminal, we can go ahead and view this down here. Here we see get API books and then the keyword returning 200. I'd like to highlight that it's using the same token created on login still. And then for this Python example, we can use this SQL code to quickly check the database. We can paste it here like this. We have an error in our syntax somewhere. Select ID, title, author, from books. There should not be this here. So we can quickly rerun this. I'm not sure why that is there. And now we see these rows are what the backend just returned to the client, demonstrating that search is backed by the MySQL catalog. So next we have FR 2.2, search by title, author. The search keywords should be matched against both book titles and author names. Previously you just saw in the clip right before this, we tested the against book titles with Python as well as with code. And now we can show the author's names. So first I will go back to the GUI. And here you see Python brought up, Fluent Python and Python Crash Course. So now let's try by author. We'll use this author. And we will click search books. And here you see a book by this author appeared. In the backend terminal, we can quickly see that the request is here. Another get API books call with the updated author name, again return 200 and the list of results. And then in the database proof, we can kind of do something similar to what we just did, but we'll change this to the author name, which is spelt like this. And we can run this. And again, we have an error. Let me find it. Same error. And we can run this again. And you can see the Lord of the Rings by that author was found by matching the author field, obviously, proving the search checks both title and author. Moving on to FR 2.3, search results display. The search results should be displayed in a clear list format showing at a minimum book title, author, price to buy, and price to rent. So to do this, we could go back. Here you see it already, but to get a few more, we can use the Python example again. Search the books, and here you see we have the book title, the book author, the price to buy, and the price to rent for each of the results. And then quickly the backend database tie-in. Again, you can see the API call there, and for this we can just show the table of the books. Let's do that really quickly. Show tables, and then we can just list all of the books I have inserted for testing using this wildcard. And here you see we have the title, author, price to buy, and price to rent, as well as the same thing for the other Python book. And we can quickly just make sure this is all the same: $29.99, $4.49, $29.99, $4.49, and $54.99, $8.49. $54.99, $8.49. So you can say these prices match and the values in the books table that we saw from MySQL earlier. So moving on to FR 3.1, buy a book. A logged in user must be able to select one or more books from the search results to purchase. So let's go ahead and find a book we want to purchase. So I want to purchase this book for $34.99. Item type, we can choose to rent or buy. We are on buy, so let's keep it there. And we can add it to our cart. On the right hand side, we see it is in our cart with the option to buy. Backend and database proof will be finalized later as I go through these functional requirements, since buying and renting happen in the same order. Next is FR 3.2, rent a book. A logged in user must be able to select one or more books from the search results to rent. So let's find a new book. Here we have this book. It's only $5.99 to rent, so let's select it and make sure that we are renting it rather than buying it, and we will add it to the cart as well. So now you see the buy from the clip before and the rent that we just did here. Moving on to FR 3.3, place order, combined buy rent. The user can finalize their selection of books to buy and or rent in a single transaction, creating an order. So to demonstrate this, we have the two items in our cart from the previous demonstrations, and we can click place order. You see a success dialog appears with the order ID and the total. So as you just saw, success dialog with order ID and total popped up. This created a single order that included both the buy and rent items. Moving on to the backend, we can see that here the post API orders request return 201. That endpoint calculates totals, created an order row, inserted order items, and updated inventory. And we can go into MySQL as well. Well, first let's copy this as a helper. And we can paste this into MySQL. And there's an error in my syntax somewhere. So we're missing a sneaky underscore right here. We can rerun this without the syntax error. Note the ID says it's 1, and now we can use this, or order ID equals 1, and execute it. So now the single order row has total amount and status pending. The order items table shows one row with item type equal buy for clean code and one item type equal rent for the programmer. This satisfies FR 3.1, 3.2, and 3.3 all at one time. And then for a bit of extra clarity, I can show you the inventory change as I prepared the SQL for that as well. And again, I have a error somewhere. And it seems to be this is a period and not a comma. And here you can see the stock quality has decremented by 1 each, confirming the transaction updated the inventory as well. So moving on to FR 4.1, bill generation. Upon placing an order, the system must generate a detailed bill. The bill should include a unique order ID, list of items bought/rented, individual prices, and the total amount due. So for the backend behavior, when I placed that order, the backend generated a bill text string including the order ID, customer email, each item with type and price, and the total. This is then used as the email body. You saw the proof in the database. In MySQL, you already saw orders and order items, as you see. The order ID we saw in the GUI matches the one in the orders table. And we can see the individual unit price for each item. These values are exactly what the email bill uses, which you'll see. Moving on to FR 4.2, email notification. The generated bill must be automatically sent to the user's registered email address. This requires integration with the email sending service. For the order we just created, the backend will call send email. If there is an issue, it'll log error sending email and return the status in the API response. but as you saw when we placed the order, the GUI showed bill emailed or something similar to that. So there's nothing wrong with this part. It's working perfectly. And we can switch to my email really quickly, and I can show this. Here's my email, and as you can see, it is the same email that was created when I registered my account at the start of this demonstration. And here is the order. So let's click on this email. So here's the email sent by the system. You can see the subject contains the order ID, and then the body lists all items and the totals, the buy, the rent, total amount, which of each, when the rental is actually due back by, and all the information here. Next, to demonstrate the manager functions, I will quickly register I'll first log out of this and register a new account. Okay, from here we can quickly go to MySQL and set him as a manager function. Perfect. And now we can log into manager view. So now concerning FR 5.1 manager login, a manager must have a separate secure login mechanism. This role should be distinct from a standard customer role. So to do this, we can use the manager account we just created and log in. And here we see we have a completely different view than a customer. It also lets us know that we're on the manager page, or the manager mechanism as it lists manager up here. On the back end, you can see proof through the login as well. And in FR 5.1 manager login, a manager must have a separate secure login mechanism. This role should be distinct from a standard customer role. So you just saw the manager I created and set the role in MySQL. So we can use this registration and the password, and we can log in. And here you see we have a complete different view, and you also know that you are on the correct manager view from this manager right here. In the back end, we can see the login again as well. And basically the GUI recognizes the role, shows the manager interface instead of the customer interface, and like I said, you can see this at the top here. And quickly, just to prove that that user is a manager again, we can use this. And we can see where the username is the one we just used to log in. The role is manager. Moving on to FR 5.2 view orders. A logged in manager must be able to view a list of all buy and rental orders in the system. So let's return to the GUI. And here you can see we can click on view all orders. And here we have all the orders, which we only have the one order that was demonstrated earlier on the customer side. So this dialog pops up listing orders with the index, order ID, customer username, status, total, and date. And so we can click OK on that. And we can also update the orders. I will skip this for now by clicking cancel. The backend proof. Here you see the get API orders, which for managers, this returns all orders, not just their own, of course. And then in MySQL, we can also get proof of this using this prepared query. And we can execute it. enter, we have an error somewhere. So I used a 0 instead of a circle and click fix this. Or 0 instead of a O, sorry. And recopy it. From here we can run it. And we see that we have the list of orders that appeared in the GUI, and it matches the rows from the order table. So the GUI matched the rows in the order table, satisfying this requirement. Next is FR 5.3, update payment status. The manager must be able to select an order and update its payment status from pending to paid. So let's go back to the GUI. We'll click on view all orders again. So index 0, order number 1. Say we want to update the payment status because the payment is currently pending, as you see. We can click on OK. The index was 0, we just saw that we want to update. OK. And we want to update it to paid. Perfect. Order status updated. We can quickly view it in the GUI again, and the same order is now listed as paid. Perfect. So from here, we can show the backend proof on the terminal line. Again, with these, the orders, and then you list the status, or the orders and then the status, sorry. And then in the database, we can use the line as the order ID was number 1, and we can see that it is updated to paid. Perfect. So just because I kind of messed up the wording again, here you see the put API orders, then the ID, then status, which requests that updates the payment status. It returns the 200 OK, and then in the MySQL, the payment status has changed from pending to paid, which demonstrates the manager can update payment status successfully. Now moving on to FR 5.4, create and update book information. The manager must be able to add new books or update their information, e.g. a book is returned from rental and available for the next one. Moving on to FR 5.4, create and update book information. The manager must be able to add new books or update their information. So to demonstrate this, let's go back to the GUI. Okay. And from here we can click add book. We can add a title. As that, we can add a author. We can add the price to buy it. We can add a price to rent it. We can add an optional genre, an optional publication year, an initial stock quantity, and boom, the book was added. Here you see it brought up a list of all the books that were already in the database, and here you see that ours was added. The backend proof of this we can see right here at Get API Books. Which triggered the Post API Books. Sorry, not the Get. As we saw in the GUI, the book was added, which triggered the Post API Books. And in MySQL, we can quickly show the updates there using this SQL code and running it, which you see it was added. So the new book row is present with the correct prices, stock, and available flag. So again, just to recap, the book was created in the GUI, which you can see in the GUI here. In the backend terminal, This triggered the post API books, returning 201, and in MySQL, it created it as well, where the new book row is present with the correct prices, stocks, and available flag. So next will be to update the book. We'll do this in the GUI. So let's just get rid of this entire list real quick. We'll search a keyword. This is the book we just created. We might as well update it. So we will click on it to select it, and from here click update selected book. We can put a new title if we want. Sure, let's just put test auto book. A new author if we want. We're going to go ahead and leave this the same by leaving it blank. A new bride price, we'll go ahead and leave this the same as well, but we'll update the rent price to $5.99. Okay, and are there any available? Yes. Or we'll just leave it blank since we already have it. Okay, new genre, we'll keep it. Publication year, we'll keep it. Stock, we'll keep it. And here you can see the book was updated. So, and already you can see automation turned to auto, and the rent jumped up to $5.99. So it is already updated in the GUI. The backend proof, here you see we actually have a put. This call is put API books, then the book ID, which returns with a 200 OK response. And then in the database, we can also see this by, I believe we can use the same SQL, but let's just update the title. So now the name is auto instead of automation. Boom. You can see that the title had been updated to test auto book, and the price rent also updated to $5.99, the updates that we made. And quickly, just to prove that automation is no longer there and that it was updated, empty set, so there's no test automation book. But again, it was updated to this. So based on that, you can see the updated title and the rent price. This confirms the manager can also maintain the catalog. So with that, that concludes and satisfies all of the testing for and demonstration for the functional requirements. I will now move on to the future considerations and extra credit demonstrations. So like I mentioned, that concludes all of the functional requirements, user acceptance testing and demonstrations, as well as showing the proof in the backend and the database. Now I will move on to the extra credit and future consideration features. So now moving on to extra credit 1, user profiles with order history. So to do this, let's first go back to our GUI, and we'll log out of the manager view and log back into a customer view. Okay, and this is the same customer we used before. So to view the functionality, we can click on My Profile. And here it has the total orders, the amount that was paid on that order, and the recent orders, the time, and all of that, as well as the customer's username, their email, and their role. The backend proof. That's get API profile, which returns basic user info plus an order history summary. And then we can also quickly show this in MySQL using the prepared SQL code. First this, oops. And don't forget the semicolon. Okay, and then this. where you can see these values match with the profile dialog, what that shows, and this demonstrates an order history style profile. Next, I can demonstrate extra credit 2, like the advanced search filters, like genre and year. So to do that, we'll go back to the GUI, and we can click OK on that user's profile. And for this, we won't even use a keyword, but we know we want the genre to be something in the software engineering software engineering field. So we'll type that for the genre, and for the year, it can be anything from 1990 to say 2010. And we can click search books. And here you see that we have 3 different results. Clean code has to do with software engineering. Design patterns also has to do with software engineering. And the pragmatic programmer also has to do with software engineering. So you can see that that is working. And we can quickly show the backend proof. Right here, where you can see get API books with the query parameters, which returns 200, and then the database proof, we can use this helper code to run, and we see that we get the same information, or the same books back, and that it all meets the required search filters. So the results listed in the GUI match these filtered rows in the database. So moving on to extra credit 3, book review and ratings. We can test this by going to the GUI, and we can select a book, say this one. We can click view add reviews for selected book, and you can see there are currently no reviews yet, but that's okay. Would we like to add one? Yes. It was a really good book, 5. And we don't have to add a comment, but we'll just add a short one just to see. Good book. Okay. From here it says the review was added. So we can quickly make sure that it was added. So the reviews for this book are here. Logan customer rated it a 5 out of 5. It shows corresponding info, and then it also shows the review. Good book. We don't want to add a new review since we just did, so we click no. The backend proof. First we see get API books with the ID and reviews to list existing ones, then post API books ID reviews with 201 created when adding the new review. And then in my SQL database, we can also use a helper code to test this. So again, we will use this helper code and show the updates in the database. And there's a typo, so let's fix this real quickly. I believe this is the issue. Okay. And let's rerun this. And you can see the rating with the comment as well as the book title, and the customer name is present. I also just wanted to show, adding on to this feature, if you were to research for this book, it now shows the average rating along with the number of reviews for that book. Next, I'll show the 2 remaining extra credit inventory management and rental returns kind of at the same time. So to do this, first I want to rent a book, let's say Lord of the Rings. Okay, now I want to demonstrate the last 2 remaining extra credit, inventory management and rental returns, kind of at the same time. First I'll start by renting a book, say The Lord of the Rings, and let's select rent. Okay, and we'll add it to our cart, and we'll go ahead and place the order. The order was placed, and here's that info. So now real quickly in the database, we can use this to show the stock quantity as well as the availability. If the quantity hits 0, the availability will then go to 0. So keeping this in mind, the manager handles returns and inventory. So we will log out of the customer account and we will log into a manager account. Okay, we're at the manager account. So now we can simply click on manage rentals, and we see we have all of the books that are out for rentals, their due dates, etc. The item that I just rented was the Lord of the Rings, and it's due by Wednesday the 17th. It's index 1, so we'll go ahead and click OK. Since for testing purposes we want to return the rented book we just did, it was under index 1, so we entered that. And we mark the rental as returned. So now the backend logs get API rentals to list active rentals, then put API order items, item ID return, which sets returned at and updates the inventory. We can now show the proof in the database. So to do that, we'll take this SQL code, but we can do this as well as this. And now we see that it was returned at this time and the quantity went back up by 1. So the inventory was adjusted as well as the rental return. So returned at is now filled and stock quantity has increased by 1. Availability is updated. This demonstrates working return rental workflow and inventory management. Also, before ending the video, I just wanted to cover a few more things. I already showed password hash in the users table. I just briefly want to iterate. The passwords are stored hashed to bcrypt, never in plain text, as required by the security non-functional requirements. And then I just wanted to mention all the API calls we've seen after login include a barrier token in their headers. Without that token, these endpoints return 401, 403, enforcing API authentication and role-based authorization. With that being said, this concludes the user acceptance testing demo. I've shown every functional requirement from user registration and login through search, ordering, billing, and manager tools, backend proof via flash logs for each relevant endpoint, database proof via MySQL queries for users, books, orders, order items, tokens, and reviews, and extra features like the user profile with order history, advanced search filters, reviews and ratings, full rental inventory, return handling, and inventory management. Together, this demonstrates that the desktop app, REST API, and MySQL database work together to fully satisfy the product requirement document and as well as the extra credit features. Thank you.